Mm. So, good morning. I am Margian Abel Domaro from BSEB Math VB, and I am here to present my Project 1, where I will make a figure with more than 12 symmetry, and then I will show if the resulting table or the table of results is a group or it forms a group. So, here I shall present, yeah, present and slide on, slide on. What's this? So here is my symmetry. So these are the moves. So R is do nothing. B is turn 90 degree. F is a 90-degree counterclockwise turn. E is 180-degree counterclockwise turn. B is 180-degree counterclockwise turn. A is flipping vertically. U is flipping horizontally. R is turning to the right axis or right diagonal, and Y is turning for the left diagonal. Okay. So here are the lines of symmetry. As you can see, there. That's so. This is one. This is two. Next, this is three. This is four. This is five. This is six. You can see six. This is seven. And this is eight. So next would be the rotational. So this is the first turn. So that's a 90-degree clockwise turn. This is a 180-degree clockwise turn. Then this is 270-degree clockwise turn. As you can see, there in total, all the symmetries are um, ayan. In total, all the symmetries are, let's count it again from the top. Um, in total, there are two there, two here, so that's four. Another two, so six. Another two, that's 10. So this is the first turn, so that's another two, that's 12. Another is 14. And lastly is 16. There. So here is the table of results when you turn them. So I label, so this is what we will call group G. And in order to know if group G is the table, then I have used three ways to prove or to showcase that it is indeed a group table. So the first one is this one. So this is the plus sign algebra. This is the plus sign algebra. This is the group table for the plus sign algebra. And if our table maps to this table, then or it is isometric, then I can say that our group table is a group since it is isomorphic already to a known group table. So here, I rearrange our table to map it here. So if N maps to R, if B maps to 1/4, if E maps to 1/2, if F maps to 3/4, if H maps to U, if A maps to V, no, if V maps to A, if R, if big letter R maps to small letter R, and L maps to Y, then is uh this is a group table. So let us see. So I use color coding to make it more clear. So sky blue, red, a darker shade of blue, pink, green, orange, purple, and darkest blue. So our first row maps. Next is red, uh, sky. No, this is the darker blue. Then pink, and then the I'll just call this teal. Then the darkest blue. Then purple. Then green and orange. So the second row also maps. Then we can also look at this. So if we match the corresponding row to what I am pointing, so U and H, this and that, we can see that it all matches. So in order to make it another way that we can visualize it is, right, so I'll just select all this table and then overlap it here. Yeah, okay, so I overlap it and then observe that there are no clash of colors, or we can see that all the colors form are one and the same. Because, for example, I'll exchange this and, and then, so I just exchange two. Then if I once again overlap, if I overlap, we can see, oh, no, that's not the perfect overlap. Let's try again. There. Like, and here we can clearly see where it does not overlap or where the colors do not match. So since the colors match, we can see, so put this back again. So since the colors match and there are no clash of colors as we can observe, we can conclude that our table is isometric to the plus, so the algebra plus sign table, which is already a group. So we can conclude that our table is a group. But if you're not sure about that and you want a more rigorous way to see if our table is a group, then there is another one here. So here are the three conditions for a group table. So first, there must be an identity element in the set. So normally, a identity element, so I'll state the definition. If it is A star A is or E star A is equal to A. So let's see here. So F star R is equal to F and R star F is equal to F. So we can see that so we can see R star E is equal to E. Then the converse or the inverse of that is E star R is also equal to E. And E is the element we partnered with R. So we can see that our identity element in the set is R. So I color coded it green except here, but R star R is R. So this is so that's the result is the identity element. As we can see, there is a identity element for each table. Yeah, for each element that is R. Next, each element must have an inverse and the left and right inverses should be equal. So it means that our inverse should have the same distance from a row and its column. So for example, R, so R star R, so that is 1, 2, 3 from the row and 1, 2, 3 from the Right. So this is because R star R is the same. So our left and right is the same. So uh, way to see that is F star B is equal to R and B star F is equal to R. And if we count R, so the distance of R from F is 1, 2, right? 1, 2. So this is our right inverse because B is in the right. And I know, yeah, B is in the right. And when our B is in the left, so our left inverse, then if we count the distance of R from F, that is also 1, 2. So as you can see, there is a distance of 2 from F, same with this. So that means that our left and our right inverse are equal. Next, each element must only appear once in each row and column of the table. And if we can see, if we look at this E here, that is the only E in this row, it is the only E on this column. If we look at this E, it is the only E in this row, and it is the only E in this column. If we look at B, once again, this is the only B in this row and this column, and in here and in E here, it's the only one in this row and in this column. So we can conclude that since there is an identity element in each set, each element must have an inverse. So we can see that each element of B, its inverse is F, E, its inverse is E, R is F, its inverse is B, and then the rest, the inverses themselves. We can say that this is a group table. So another way is if that is still you're still unsure of that, a more rigorous way is to check if our table itself has is a group. So first is we check if this is closed. So we look FEBRUARY. This is a closed table. All the results are all in these elements. There is no result that are not a part of the element. So next is to check for associativities. We check if we flip it 180 degrees, and then our result must or we can rearrange so that it also looks like this. So in here is if we rearrange that. So I had here. So let's rearrange it side by side. So we look at the red here, not this part. It's here that we must look at. So our first is E, then B. So EB, first is that, and then B, so EB, next EB, so big letter R, A, R, Y, so big letter R, so like that. So we look at that, so big letter R, maybe adjust that there. So big letter R, and then A-R-Y, so next is A-R-Y, A-R, so A-R-Y. Next is F-U. So lastly, so I know this is also a Y. So YF. So let's just use drag both. So F, so Y and then F, so FU. So yun na lang. Then we just put the last row in here for yeah. So this is the look of our table. And then if we can see, this is still not a match with our main table because the columns, I know the rows are misaligned. So next is we must align our rows. So this is EBRY. So our F, so our first column is already right. And then next is EBR, right? Is it EBR? Yeah, EBRUY, EB, EB. Is it big letter R? Yeah, big letter R. So RUY. So eto, magkakasunod-sunod pala silang tatlo. So RUY, then and RFA. Okay. So wait, let's completely finish this table here first. So I'll zoom in here. And if we look at the table, so this is our finished table layer. So this is the finished the table that we just did. And then this is the original table. So let's look at this and this. This would be the margin. So February FU with the big letter R first. So that's check. Next is BR flower. So BR flower. Next is R theory RBA. R theory RBA. Next is Uyarf Bere. Uyarf Bere. Next is Yarbreo. Yarbreo. Next is Roy Ferrab and Roy Ferrab. Next is February. February. And lastly is Aro Befir. Aro Befir. So since this and this is a match, our result match, we can say that this is an associative table. Next is we just check if there is an identity element. So once again, there is the identity element R, and each table or each element has an inverse, which means that if you operate each element to one element, so for example, if you operate F to B, E to E, B to F, R to R, U to U, A to A, big letter R to big letter R, Y to Y, is that you will have there is that the result is the identity element R in our table. So there is an identity. So there is an inverse element for each element. And since we just proved that there it is closed, it is associative, it has identity element and it has an inverse, we can conclude that our table is a group. So that is for our activity number one. And I will see you next time for our final project number two. This once again, this is Margian Abel Domaro, and I thank you. Stop sharing. And recording. Stop recording.